and S are next to each other, Q, R, S are next to each other, we're looking for the roots. Because when we have functions, we call them zeros. Okay? And sometimes it's a little bit confusing. And the way I remember that is, and when I say the word functions, I hear that zzz, functions have zeros. Okay, so it's just a little bit of a difference of definition, and I just want to make sure that everybody's clear at that. So when we're talking about solutions to an equation is an equal sign, and it's equal to 0, it's in standard form, we're talking about roots. And when we are talking about just the function, it's in function notation, or I mean I could use y equals. When we're talking about a function, they're called zeros. Okay, and we're going to proceed with that a little bit more.
What's called zeros?
It's called a zero functions, or when it is when we have a function. And if I were to graph, and I'm going to have you graph this in a second. Please graph. Can I move this piece of paper, everybody?
So all functions are called zeros?
Yes. When we are, and I'll tell you what we're going to be looking for in a second. So I would like you to graph this equation. Let's go with x squared. I'll zoom in on that. Sorry. Graph x squared minus 2x minus 3. Is that a, are we looking for the zeros? Or are we looking for the roots? Zeros, because that is a what? Function. Okay? That's a function. So I'm looking for the zeros. Please graph it and tell me where the zeros occur. Okay, how many are there? Everybody has 2? Everybody agree with that?
Yep.
All right, so you should have something that looks like this. And we say that it has 2 real roots, right? Are they on the number line?
Yeah.
Those numbers exist? Okay, so we have 2 real numbers and 2 real roots.
But those are zeros because it's a function.
Right. Sorry, they're roots. Zeros, sorry, they're zeros. You're absolutely right. Okay, let's try this one now. The next one is x squared minus 2x plus 1. First of all, think about that. Is that a perfect square trinomial?
Yes.
That is.
That's
Okay.
so hard to find.
What? Was that a hard one to do?
Wait, I have to
No,
change my
because it's
window.
only one square.
Okay, how do I change the window? Zoom,
Or hit window.
6,
Oh, the stamped.
right? Okay, and in this case, we have a function. So what are we looking for? Functions have zeros. And how many does it have this time? 1.
Why does it just take one?
Why does it only have 1? Because it only touches in one spot.
So you're not looking for the intersection, you're looking for
We are looking for where it crosses the x-axis. For this one, it crosses twice,
x squared minus 2x minus 1?
plus 1.
Plus 1.
Okay, Stephen?
So that means in this case, its minimum is 0.
Yes, yes. Okay, one more. Okay, you ready, Mike?
It should be where it touches 0 on the y-axis.
Yep.
Okay, you guys ready? Okay, one more. Let's try this next one and tell me what you see. Where am I?
Too far.
Lost my
Go back.
page. Yeah, let me see. Where's my finger? Right there. There it is. Okay, so try x squared minus 2x plus 3.
0?
It doesn't
What
cross
happened?
the
So
x-axis.
function.
Doesn't, is that a function?
No.
It has to be.
Yes, it's a function.
It is a function. Think about
This is having a
this.
zero.
Does it touch the x-axis?
So-
No. So, do you remember we talked a while ago about imaginary numbers? Could it be that it does not have real roots, but it could have something else? Okay? So, that is what we are going to be looking for. We're going to be looking for if a function has, or an equation has, two real roots or zeros. It could have one, or it could have none. All right, so you might want to just jot that down in your notes, and I did not write that down, but we have three, you could copy these three equations down that you had and do a little sketch. If you want, I can write this darker. This one was y equals x squared minus 2x minus 3. This one was y equals x squared minus 2x plus 1. And this one was y equals x squared. You can see that, is that minus 2x plus 3. Okay, and that when we graphed them, we have either two real roots, or we had one real root, and it has one real root because why?
Because it's a perfect square.
No, because it.
No, that's not why it has one real root.
It doesn't cross the, like, 0.
Okay, it only crosses the x-axis at that one point, that it touches at the vertex. And in this case, it doesn't touch, so it does not have any real roots. Okay. Let me see. Are we good?
Mm-hmm.
All right, so I'm going to give you your homework in a second. I'd like to do this one little word problem with you first, and then I'll give you your assignment. I'm on page 343. I kind of like the word problems because they make sense to me. And oh, come on, these aren't bad. All right, how many of you have ever seen one of those big blimps that go over like a sports field or something? Wouldn't you like to go in one of those sometimes?
Not really.
Not really. I think they're pretty cool.
I'd be kind of afraid it would like pop.
Pop. Okay, well, I think I'd be happier with one of those. So,
Airplanes crash.
all right, this is on page 343 in your textbook. The picture isn't very good here. So during the opening ceremony of a baseball game, a colorful display is to be dropped by a blimp, hitting the pitcher's mound during the last note of the Star-Spangled Banner. Good call. The blimp will be at an altitude of 1,000 feet. Okay, I hope we're thinking altitude. Do we have a formula maybe in mind? I hope.
Yes.
Because we're going to be dropping something.
T squared.
Okay, and the blimp will be at an altitude of 1,000 feet. A student will signal the blimp with a light when it's time to draft the display. How much earlier than the last note should the signal be sent? So if we're looking for where it's going to be, we have our negative 16 t squared plus, why is it 0t? 0 meaning 0 velocity, okay, plus 1,000. I'm just going to show this to you quickly. When they graphed it, you think we're interested in this negative?
No.
No. Okay. What does this represent? How many seconds for the ball to do what? Hit the ground. Okay. So again, this models that equation models the path that the ball would take, or models how long it would take. All right. So let me give you your homework. I hope you find that you're feeling a little bit more comfortable with the equations. And I'm just going to write the assignment down in a second. It's right there. Okay, so let's start, we'll do the reflect tomorrow. So page 344, 45, 1 through 17, no, and 26. 1 through 17. Some of them are very, very easy little problems.